Okay, so let's continue. I'm gonna use this directed graph as an example and show you guys how we can use the DFS to find the cycles. Let me see where I want to start. So let me say I want to start from 1, okay? So and then we are doing a depth first search. So we start visiting this node at the time 1, and then this one now is gray, right? So gray. And then we move down and visit this node, and then we start at time 2. And then from this node we can go nowhere, so we stop that. So now this is black. Okay, and then after here we go back, and from this node 1 we have nowhere to go, so we finish visiting this one here, and then it will also be black. Okay, so we just visited the 1 and the 2, and after that, and there's no 3, so I want to move on and do a visit 4. So we start visiting 4 at 5. Okay, so in this case, from the 4, we can go to a black node, and this means, well, we have already finished visiting the node 1, and now from 4 we can go to the node 1 again. So that is from a gray. So the 4 is a gray. From gray we can go to a black, so that is still okay. And then we move down, and then we can visit 5, and so for this 5, and we have the start time at 6. So and then from the 5 we can go to the 6, so now it is 7. Okay, now we have the problem. So for now this 6 can go back to a gray node. So number 5 is a gray, and number 6 is a gray as well. So from one grid node, we can go to another grid node, and then we can say, okay, as long as we see there is a such an edge, go back to a grid node, and then we can say there is a circle. So if we only want to return a true saying there is a circle, and then that is the right time, and then we can simply do a return true, saying we have already got a circle. Okay, so the next part, well, we want to introduce a new concept called a directed acyclic graph, well, or a DAG, a DAG. So it is a directed graph and without the directed circles. Okay, so that is the concept of DAG, and using the concept of the DAG, and we can do some other things. So the first thing we want to try is we want to argue that in a directed graph, which is G, and it has no circles, if and only if that we run a DFS, and then there is no back edge. So if we want to prove this in the forward way, and then if if the graph G is acyclic, and then, well, there should be no back edge, and otherwise, well, if there is a back edge, and then this back edge itself will close a circle, and then we do have a circle. And another way that we can argue this is, well, that is let me write something down here. So, well, what we are trying to say is, uh, say, hmm, wait, what is it? So, a cyclic G, and means, in the DFS, no back edge. Okay, and, well, we can argue that in another way, which is, if there is no back edge, and then the G is acyclic. So, well, if there is no back edge, so this means there is no possible circles got close with a back edge. So in this case, well, we can say if we do a DFS and we didn't find any of the back edge, and then we can say this graph has no circles. So well, the concept here is, well, if we want to run the DFS, and then you can detect whether a graph is a DAG or not. And the next thing, it's a really funny topic. So topological sort. And what we are trying to do is, well, if we have a DAG, so a directed graph without a circle, and then, well, we can come up with a sorting, and from if we follow the sequences, and then we won't violate any of the sequences. So if we want to do a very small example, say from A to B, and then from B to C. So if there are just three simple steps, and then we simply have to do A first, and then we follow by B, and then followed by C, right? Okay, if we want to make it a little bit harder, so if we have an E here, and then what is the right sequence to do those four steps? So we can do A, B, E, C, right? So we finish A so that we can finish B, and then we finish B so that we can finish C. So this is a DAG, so a directed graph without circles, and then it defines on the sequence required for several steps. So if we want to do a topological sort, and then we have to come up with a sequence that we can, well, when we move on from one node to the next, or when we move on from one step to the next step, and then, well, the topological sequence can be satisfied. Or I can give you another one. So how about we do A, and then we do E? No problem, right? So after doing A, and I can start E, because E doesn't require any pre steps to start, and then I will do B, and then eventually I will do C. So that is also okay, right? Okay, so this is the idea of the topological sort. And one of the real world example is how we can get dressed. Well, when we get dressed, and there are several important steps, and we just can't do that in the reverse way. So for example, if you want to tie your tie, and then before doing that, and you have to dress your shirt, right? So this is another example of the DAG. And then, for example, you have to after tying your tie, and then you can put on your jacket. So this is the common way, and our task is, how do we come up with a sequence that we can properly get dressed, and following all the requirements on which step I should do before the next step. And I can give you one example, and this may not be the only example, but this example will meet all the sequences. So for example, I can put on my socks first, and then after the socks, and then I can put on my shoes, right? And then if I want to do the I want to have my t-shirt on, and then I do my belt, and after that I tie my tie, and finally I put on my jacket. So this is just one way that we can get dressed, and of course, as we have seen here, there can be multiple ways that we can come up with the sequence of the steps and meeting all the requirements. Okay, so how do we come up with a possible solution based on a DAG, and so that we can do a topological sorting? And actually, we have already able to do that, and that is, well, for a topological sorting, and then we can simply do the DFS, and then after doing the DFS, and then we just put everything in the reverse order, and then that is the topological sequence. And the time, of course, it is still OV plus E. Okay, so let me use this one as an example. So if I want to start from here under wire, so I do 0 here, and then I move down, and I start to visit, depends on, oops, it should be 1, and then I move down, and then my belt is 2, right? So after the 2, and I can do nothing more than that. So I finish that, and then I do a 3. So this belt will be the first black node. So I'm doing the belt here. And then after that, the next part I can do the pants. Okay? Well, and for the pants, I can move on to the shoes. Okay, so here the shoes will be, oops, it should be the time 4 here. Okay, and then it is a time 4, and then from the shoes it can go nowhere, so I have to put a 5 here. So shoes will be the second black node we have, and after that we go back to the pants, and then it seems that we can do go nowhere from the pants, so I'm gonna finish the pants here on the time 6. So the pants will be the next black node, and after that, how about the underwear? So for the underwear, we can go to the shoes, but the shoes has already been done, right? So in this case, and I can say, okay, I want to finish my underwear, so that is the time 7. So underwear now is also a black. So I'm gonna put the underwear here. And after that, we want to move on to the shirt. So how about I do the shirt as the 8? So I start my shirt at the 8, and the shirt can go to the belt, but belt is already a black node. I don't have to visit it again. And then I can move on to the tie. So I start to visit the tie at the time 9, and then start to visit the jacket on the time 10. So on the jacket, and then I say, okay, well, there's no more thing, so I want to finish the jacket. So jacket will become black. And after that, tie will be black. And after that, shirt will be black as well. So we will have the shirt. Okay, and then we have the time 14. So starting from the 14, I want to visit socks. So socks. And then for the socks, I can visit the shoes, but the shoes is already a it is already a black. So in this case, I can close my socks here. So that's in my socks. And then eventually I will have the watch at 16 and 17. Okay, so that is my watch. Okay, so well, if you follow this step, and I have been using the DFS, and then for each of the node I have finished, and then I read them. I write it down in the reverse order from the bottom to the very top, right? So now if you want to take this sequence and then do a top down, and then I can put on my watch, and then socks, and then shirt, tie, jacket, and then underwear, pants, shoes, and belt. So this is a sequence that I can get properly dressed, right? So well, I just did this algorithm. So I just run the DFS, and then well, when a vertex is finished and output that, and then for the vertices are output in the reverse order, and that is the topological order.